Why do we need containerization? So one of the reason is having or avoiding compatibility issues. Provides solution to many challenges, consistency, scalability, efficiency, and how does it do that? So basically, IAC, you remember when we learned Ansible, we learned about the IAC chart. IAC has three main categories, right? One of them is provisioning the infrastructure. Another one is configuration of the infrastructure. And the third one is templatizing the infrastructure. So what do we mean by templating it? So basically, what do we mean? We mean that whatever piece of code, it might be anything. It might be a complete application itself. It might be a small API. It might be a microservice, or it might be any piece of code, right? Along with that piece of code, what we do, we also write the requirements. I mean, what are the requirements in according to go ahead and in according to run this piece of code, right? It might be a dependency in terms of installing Java, installing a web server, or installing anything, right? It might be the dependency along with your piece of code, and along with that, whatever compute requirement we may have to run that piece of code. So putting all these things together and wrap it up into a tiny thing, right? That's what basically a container means, right? And that's exactly why, and that's exactly how it avoids the scalability issues or probability consistency or even the compatibility, right? And compared to any virtual machine or compared to probably any server, it's very lightweight, right? I mean, in a server, we do have a complete operating system. We do have all other things, right? Compared to that, as it is virtual and as it is very lightweight, so it doesn't take that much of amount of time if it has to scale in terms of numbers, right? So when I'm saying scale, it doesn't mean it will scale vertically. It will scale horizontally. Meaning what? Generally, with containerization, we do not go and we do not modify the containers because the nature of a container is volatile. Okay, the nature of a container is volatile. And we'll talk about all these things like when we will see. So that's basically the necessity of a container. Okay. Now, first thing first, how do we install Docker? So Docker comes with many offerings. Okay. Now, for Windows specific things, Docker has its own Docker desktop as an utility, right? Which is nowadays, initially it was completely free, then it got paid. Along with that, Docker also comes as a community edition, which we say Docker CE. Community edition, right? And you can go and you can just install that Docker anywhere. So official Docker website is this docker.com, and you can see this is the official website. Okay. Now, if you just go to scroll it down and if you just go to docs, the documentation, right? Here you will see all these things, right? So in terms of Docker engine, you see the install and there are instructions available for every operating system, right? And here is the supported platforms by Docker. Okay. So if you see now, so in case of Ubuntu, yeah, all kind of architectures are supported. See, all types of architecture. It might be AMD processor, Intel processor, or even like an x86 architecture or even ARM architecture, anything. So for Ubuntu, everything is supported and such like that. For Red Hat, you see only Intel and AMD are supported. ARM 32-bit is not supported. So here is the compatibility chart if you want to install Docker on specific operating system, right? So for now, we're going to go and we're going to use Ubuntu. So if you go to Ubuntu, which all versions are supported. So here are the all versions of Ubuntu are supported. Right now, Ubuntu Jam 24 LTS is the latest one, right? But yeah, it also has the backward compatibility of Ubuntu 20, Ubuntu 18, and even 16 LTS are not supported because those has been declared as an end of life. Okay, cool. And if you just scroll it down, here are the instructions to go ahead and to install the Docker. Okay, so of course you can also install Docker desktop for Linux, right? Or even Docker from apt repository. And here are the same instructions, right? But as we are using EC2 and we would be looking from the command line, so I would be installing the Docker CLI version, basically Docker CE. Okay. So first thing first, I'll just log in to my machine. Just taking an update. All right, so this is done. So now let's just execute all these instructions in according to install Docker. Okay, so what does these instructions means? So I'm just adding the repository, okay, and simply going ahead and simply taking an update and install the Docker. Once we are done, so if you want, you can install the by default latest version in according to go ahead and in according to install the Docker. Or if you want to specifically go and install specific version of Docker, you can just go ahead and just follow these instructions. Okay, I'm just going to go with the latest one. Okay. Okay. All right. So, is it Docker has been already pre-installed, or if it is already installed, which version of Docker is installed in the labs? Is it the latest one or the older one? I have installed Docker, and Docker requires sudo permission. So easiest way would be I will just turn to sudo, or if you want, you can also give instructions to convert or give root access to the Ubuntu user, right? So that's what you can do, right? But I'm not going and doing that. Okay, cool. So now which version we have installed? So we have 27.4.0, which is latest one. Okay, cool. So obviously, if I don't know, I don't have live access, so I'm not sure whether which version has been installed in the labs. But yeah, depending upon the version, behavior of some certain commands may change. The older version, obviously, you can understand. The latest version, they will improvise, right? So yeah, just take a note of it. But preferably, more or less, it won't be drastic change that some commands will not work in the older version. Nothing like that. Probably some of the syntaxes or some advancement might have been done probably in Docker volumes or something like that. Okay, but cool. Let's go ahead and let's look at it. Now, the very first thing, so we have installed Docker version 27. So basically, how does Docker works? So first of all, let's have a look at the architecture of a Docker. Now, first thing first. Just like we have installed Ansible. So once you install Ansible, what we call that machine where you install Ansible? What we call that machine? Ansible controller, right? So now just like that, when you install Docker, definitely you will need some certain machine to install Docker. At the end of the day, it's just a tool, correct? So wherever you install Docker, we call that machine as a Docker host. Okay, what we call that machine? A Docker host. So assume this is your Docker host. In this case, this EC2 is our Docker host. Got it? Okay. Now, once I install Docker, so Docker gets installed as a daemon. Okay, daemon. Daemon means what? Some certain process which runs in the background. Okay, some certain process which runs in the background. So assume this is your Docker daemon. So a Docker daemon gets installed, which will listen to all of your commands and everything, right? Something like that for simplicity. Now, if you want to run basically a container using a Docker, again, Docker is what? Is it a container runtime or it's a container management or orchestration tool? What is a Docker, guys? It's a container runtime. It's not a container management tool or container orchestration tool. No, it is just a container runtime. What does that mean? It means Docker will help you only and only with what? Creating containers or stopping containers. That's all. Whose responsibility is this? to keep your container running, or even accidentally, let's say because of some X reason, that container goes down, then whose responsibility is this to bring that container up? Is it something Docker will do automatically? No, it would be your responsibility to take care of your containers. Is that clear? Okay, that's the difference between container runtime tool and container management or orchestration tool. Okay, what does container orchestration tool or management tool does? Once you instruct a container orchestration tool to, let's say, you instruct some container orchestration tool saying that these are my 2 containers, make sure that you run them always. That's all. Then even if those containers goes down, then automatically that container orchestration will do everything which is required to bring them up, and it will do all the things in according to keep them running. Okay, that's the major difference. So what are the examples of container runtime? Podman. What else? Docker itself. Apart from that, containerd, correct? Rancher. Okay. Cryo, right? These are all open source, like, container runtime. And what would be the example of container orchestration tools? Kubernetes, Docker Swarm, correct? Mesos, right? Apache Mesos. Now, let's go ahead and let's discuss how this Docker works. Now, first thing first. So definitely you by now, okay, so once you install Docker, it will install your Docker Daemon, right? Now, this Docker Daemon basically has a couple of things, like, as a part of it. So by default, what it does is, once you want to run a container, right, it requires something. Let's say you want to run a container. All right, but this container, basically from where it has to run? For simplicity, look at this. When you want to launch an EC2 instance, what is the important thing that you tell? What is the important thing that you tell? Something like that. Which operating system it should have, right? Or from which OS image that EC2 instance should run. So just like that, when you want to launch a container, let's say this is your container, then you will have to tell that, okay, how that container should be launched. So what that container should contain actually, right? So we tell that using Docker images. Okay, how we tell that? We tell that using Docker images. So where are the Docker images then? Look at it. Right now we just install Docker, right? So practically speaking, from where all these images will come? So just like that. So just like with Ansible has some predefined modules already. Jenkins also has some predefined plugins already. Just like that, you also have some images. When I'm saying some images, literally hundreds and thousands images predefined. When I'm saying predefined, someone already made images. And all these images are hosted in some certain location over the cloud. Okay. So all these images by default are hosted on some certain space or somewhere in the cloud. And what we call that space? We call that space as a Docker Hub or Docker Registry. And what is the purpose of Docker Hub or Docker Registry? What's the main purpose? To host the images. Which images? Docker images. Understood? So whenever you want to launch a container, okay, whenever you want to launch a container, the default behavior of a Docker is what? It will try to find that image in your Docker host here. If it doesn't find the required image, then what it will do? It will by default go and it will by default download that image from where? From your Docker Hub or your Docker Registry. Now, all these images are, someone has built them already. Majority of the images has been built by Docker itself for simplicity, right? So does it mean can't we create our own images? No, definitely. If you want, you can always create these images by yourself as well to satisfy your needs. Okay. On top of it, the default registry where all these images are hosted is Docker Hub. Does it mean can't we have our own registry? Yes, you can also set up your own registry, right? But by default, the Docker will point or will use the default registry as a point of contact to download the images from there. So let's say this is your container and these are your images. Okay, so if you are building up your images by yourself, and if you want to definitely push them to a Docker registry, what you can use? You can use Docker push. Just like we have GitHub for a piece of code, you have Docker up for your container images. If you want to push your image or upload an image to Docker up, you will use Docker push. If you want to download an image from Docker up, what you will use? Docker pull. Exactly. Just like GitHub. Right now, let's say what all things and what all commands that you can use with or specifically for containers. Then you can use these kind of commands. Let's say run. Run means what? Create and start a container, right? Create and start a container. Run. Then if you want to stop a container, then Docker stop. If you want to start already created container, then Docker start. If you want to freeze or pause the container, Docker pause. If you want to list all the running containers, then Docker PS. If you want to, let's say, kill the container, then kill, right? If you want to, let's say, remove the container, then Docker RM. And if you want to get more information about the container, then inspect. Okay, these are kind of commands which you can go and you can use, okay, with Docker containers. Okay, let's say for Docker images, what all things you can use. Let's say, for example, for Docker images, you can definitely push to upload the image to Docker Hub. You can do Docker pull to download the image, right? Then if you want to remove an image from your host, RMI. If you want to get more information about the image, then Docker inspect. And you want to list all the images in your machine, then Docker ls. Okay, all right. And obviously, if you want to build your own images, then important is Docker build. Okay, these are general and very widely used things which you can, or operations you can do with images. And all these keywords you can see. So these are actual commands. And important thing is, if you want to interact with Docker CLI, then you will have to put Docker keyword in front of every command. So for now, is this clear? All right. So now let's get started with very simple scenario. Okay. Now this Docker Hub, the URL of this Docker Hub is what? This hub.docker.com. hub.docker.com. Now on this Docker Hub, you can see all sort of images. You can see all sort of images. So all these images are generally categorized into three categories. Okay. What do we mean by this? So first, images which has been built and maintained by Docker itself. We call those images as Docker official images. So if you go here, you will see all the images by default which are built by whom? By Docker itself. Okay. And they are maintaining those images as well. Okay. Now, verified publishers, meaning what? Meaning third-party organizations which have built these images and they are maintaining it. So for example, what would be the scenario where probably Docker could not go ahead and Docker couldn't create an image for that particular thing? So the scenario is, let's look at this Datadog. Is it an open source thing? Is it an open source tool? No, it's a paid thing, right? Correct? It's a paid thing. So if you look at it, Nginx, look at this Nginx. So this Nginx, right? Or even all these different images, name, Redis, or even Postgre, Python, Node. These are what? These are open source tools. Correct? What does it mean? There's source code and everything else which is available publicly. That is not proprietary to any vendor. So anyone can just get their hands on the piece of code and they can modify if they want to, or they can do something if they want to do with it. Correct? Right? Will it be the case with all these proprietary tools, guys? For example, Datadog, do you think? No. So forget about even Docker. Do you think anyone apart from Datadog can do something with it? Modifying or doing something about it? Can they do it? Anyone else apart from Datadog itself? No one can, right? Because it's proprietary thing. So that's where all these organizations came forward and they have created images for their respective tools. Okay. And just like that, the third category would be the sponsored OSS, meaning what? Sponsored open source tools. Okay, for example, FluentBit. So FluentBit is an open source technology. Yes, but practically speaking, it's not community driven, right? So in according to create an image and keep it updated, they need a sponsor. So that's why they got a sponsor, and that open source sponsors are doing or paying for maintaining and creating these projects. Okay, so there are these three category of images, all right, in terms of just using it. So which one to use? Definitely you are free to use any kind of image you want to. Okay, if you click on any of this, right, if you just click on any of this image, so all these things you can say these are image repository. Just like you have your repository in GitHub, these are what? These are repositories for those respective images. Got this, guys? Okay, and definitely as it is a repository can be public or private. Correct? Repositories can be public or even private, right? What does it mean? So right now, all these images which you can see, or all these image repositories which you can see on your screen, can anyone tell me what kind of repositories these are? Public or private? Public. Correct. And how can we be sure of it? How can you tell us confidently that these are public images or public repositories? Because of course, guys, are we logged into Docker Hub right now? Are we logged into Docker Hub? We are not. Correct. So it means exec is in there. These are accessible to everyone. We are not even logged in. And if you can still see that, definitely, what does it mean? It's a public repository, right? If it would have been private, then definitely, unless and until you have an access to that image repository, you wouldn't be able to see that here. Okay, cool. So if you want any kind of image, so you can simply go ahead here in the search bar and you can just look for any image you want to. Let's say, for example, I want to look at this image, hello world. Okay, here is the hello world image. All right, now understand. So if you just click on it, you will be able to see a tag here. I mean, you see this Docker official image? It means it's Docker itself has built and maintaining this. Okay, now every image repository which you open up, so it will have a quick references, right? Including the GitHub link for that image. What does that contains, if there are any errors or not. So it would be maintained in a GitHub. So you can quickly look at it. No worries. Then how to use this image, right? And all these quick instructions would be given here in the image overview itself. You can refer to that, right? If you want to get clarity about any image. Now, very first thing that I'm going to do, very simple is, let's say I want to run a container from this image. Now look at it. Let's say I will go and I will say Docker, and in according to run or basically create a container. So which command you think we should use? Docker start. Look at it. Which command you think we should use? Docker start, run, pause. Which one? What do you think? Docker run, not the Docker start. The behavior of Docker start is it will start a container if it's already created. But in this case, we don't even have a container. Do we have a container? No. And how can we check that? So we can check that using Docker PS. Simple. So PS, what PS will do? PS will give you the list of all the running containers. Okay. PS will give you all the list of running containers only. But let's say if I want to look at all the container irrespective of whether it is running, it is stopped or killed, irrespective of that. Then if I want to see all the containers, then Docker PS-A, which will give you list of all the containers. So do we have any containers as of now? Not at all. Cool. So now let's say I want to start, basically I want to create and start the container. So how can we do that? Docker run. The minimal syntax is Docker run, and give the name of the image from which you want this container to be created. Okay, give the name of that image. So let's say in this example, which image we want to use? Hello world, right? And it's case sensitive, so make sure your image name has to be exact. So I'll go and hello world. Got it? So as soon as you run this, now understand very carefully what is the default behavior of Docker. If you run a container, then Docker will try to find the image where on the local host. And if it doesn't find the image, then what it will do? It will download it from Docker Hub, right? Basically your container registry, the default container registry. right? So can you read the first line? Unable to find image hello world locally, right? Because just like we didn't had any container, just like that we didn't also had any images, right? So that's why it couldn't find this. By default, it is pulling the hello world image from the Docker Hub, right? It will automatically pull if it's not able to find. And behind the scene, definitely what this would have been using Docker pull itself, right? So if you want, you can manually also download the image using Docker pull and image, right? You can also manually do that, but the progressive behavior of this run is if it doesn't find, it will automatically pull the image, right? And it is like, it is downloaded and now it is running your container. And this is the output from your container itself. This is an output from your container itself. Okay. Now, so what is the image name which we used? Hello world. So what is this hello world latest? We asked this Docker to run a container from this hello world, right? But it is instead of looking for hello world, it is looking at hello world latest. Why? Because here in real life everything has versions. Let's say for example right now I'm using this tool to draw some diagram. It also has some version, right? You see this version 25.0.3, correct? Some version. So in container world, all these images also has versions. Okay, and what we call them? We call these versions by the name of tag. Okay, and how do we specify tags along with images? So we specify something like this. Let's say your image name is hello world, then colon, whatever version or basically tag you want to use. All right. And if you don't specify any tag, then by default, which tag would be used? Latest. Okay. Now don't get confused. These are just tags. You can tag anything, just like you can create any kind of version of anything, just like this. This is just a tag. Latest, the default behavior is if you do not specify the tag or version with the image, then by default, Docker will look for which one? The latest one. Now, latest means, don't get confused. Latest does not means latest. I mean the lastly created image. No, it does not mean that. It means that whichever image of hello world will have this tag latest. If you look at it, look at the hello world and you see these tags, these are basically versions. And look at it. If I even list them by the newest one, you see which one is the newest one? This one, correct? You see, and somewhere you see this latest. So whichever image will have this tag latest, that will get downloaded. Let's move next. Now we have created this container. So now as this container, what do you think? How can I check whether the container has been created or not created? How can we check, guys? Again, do the Docker ps. Can we see any container? No. Does it mean container we haven't created the container? Does it mean that? Of course no, right? We cannot see any output in Docker ps. What does this mean? It is not running. Then what has happened to this container? So if you do the ps-a all, do you see this? One container now you can see which image was used. This image was used, right? So when it got created 6 minutes ago, what is the current status? Current status has been exited. Exited meaning what? Completed successfully, and it will also give you the exit code, just like your shell command. If it is 0, it means there was no error. It has successfully got completed, right? Executed. If it is non-zero, then definitely there was some problem or because of some error, it got exited, right? And if it has any ports map, so it will show you here and the container name. Okay. Now the important thing to note, if you want to interact or do something on a container, then what can you use? You can use either container ID or container name. Okay, you can use any one of them, either container ID or container name. So for example, let's say if I want to start this container all over again, then how can I start it? Docker start and give your container ID or container name. And you see now what it is saying when it got exited just 4 seconds ago, just right now. Understood? Now, let's say if I run this command all over again. So what's going to happen, guys? If I run this command docker run hello world, what will happen? What do you think? So for example, if I run this command all over again, what do you think what will happen? Will it create a new container, or as we already have one container from hello world, it will start the same container again? What do you think what will happen? So if you execute this now, look at first, you see we have executed the command, and now definitely the default behavior is it will try to find an image locally. So do we have this image locally now? Hello world? Yes. So that's why it has just ran the container from the local image, right? And this is the output from your another container. Look at it. Docker ps-a. Can you see now two containers? First one was this 27 something, right? 2e7, right? And another one is now d8 something. So now there are two different containers. So every time when you execute docker run, what it's gonna do? It will create a new container.